All right, so now that we've learned about the observer pattern in TypeScript and seen a basic way to implement it, the next pattern that we're going to take a look at here is called the strategy pattern. Now, the basic idea of the strategy pattern is that whenever there are multiple possible ways to do something, right, whether that's doing something like calculating how much a customer owes at checkout or sorting an array of numbers, right, there are multiple ways to do that using different algorithms, we should represent each unique strategy, right, or each unique method of doing something as its own class and have them all implement a common interface. Now, I understand that that might sound a little bit confusing, so let's just take a look at what this looks like in code. What we're going to do is we're going to create a new file called something like strategy.ts. And inside here, we're going to use the example of allowing a customer to check out by paying in several different ways, right? So if a customer wants to buy something off of an e-commerce site, they can usually pay with a credit card, or they can pay with PayPal, or they can pay with some other app. There's usually lots of ways that this can happen. Now, in order to prevent all of that complexity from getting into our payment processing logic, what we're going to do here is we're just going to define a simple interface, which we'll call something like payment method. And this interface is going to have a single method called something like process payment. All right, and that will be void. And we, of course, won't add any implementation since this is just an interface. So now that we have this interface, let's think about a few different ways that we might want to allow customers to pay, right? One is obviously just using a simple credit card. So for that, we might say class credit card payment method. And this is going to implement our payment method interface. And it's of course going to have this process payment method inside of it. And for now, just to keep things simple, we're not actually going to process any credit card payments. Of course, we're just going to print out a message to the console saying collecting the user's, and here we'll do apostrophe S with a backslash there, credit card details. There we go. And of course, inside here is where you would have all of the actual logic for collecting a user's credit card details and getting those verified, etc. So now that we have our credit card payment method, let's add another class. We'll call this something like PayPal payment method. And this is going to also implement the payment method interface. And then we'll also add the process payment method. And for this one, we'll just have this log out something like sending the user to PayPal for verification. And we'll have the ... after that as well. And just for good measure, we'll have one more class and we'll call this something like Google Pay method or whatever it's called. I think it's called Google Pay. We'll just use it and go with it. So this is also going to implement the payment method interface, and we'll add the process payment method. And for this one, we'll say console.log, and we'll say something like sending the user to Google to pay. And that's all we really need to do, right? And obviously, each of these process payment methods here would have quite a bit more logic in here for doing the actual logic required for having the user pay through PayPal or with a credit card or through Google Pay or whatever. But that's not the point. The real point here is now when we actually create the checkout flow for our application, which we can just define as its own class, right? We'll say class checkout flow. What we're going to do is just give this class a method called something like checkout. And what this would do is it would take something like a user's shopping cart and it would actually check out using one of the above methods. All right, so in this case, all we really have to do, I'm not actually even going to add any arguments to this checkout method. What we're going to do is we're just going to check to see which method, right, which checkout method a user has selected for paying for their cart, and we're going to create an instance of the corresponding class and tell it to check out. All right, so now all we have to do is add some kind of argument to this checkout method called something like selected payment, right? This is just going to be a string that we'll use to select between these three different payment methods. And as the type here, we'll actually just do credit card or PayPal or Google Pay. All right, so those are the three options here that we can pass to this checkout method in order to kick off the checkout process. And now all we need to do is create a corresponding instance of one of these classes in order to process the payment. So what that's going to look like is we're just going to say let payment method, and that's going to be of type payment method. And note here that payment method is the actual interface, not a specific class, right? Because now what we can do is we can use this value of selected payment to choose which class we want to create an instance of. So let's just first of all check to see if selected payment is equal to credit card. All right. And if it is, what we're going to do, we'll use a ternary operator here, I suppose. What we're going to do is create a new instance of credit card payment method. Otherwise, what we'll do is we'll check to see if the selected payment is equal to PayPal. And if that's the case, what we'll do is we'll create a new PayPal payment method. Otherwise, we'll create a new instance of Google Pay method. And that's all we really need to do. So now we have this payment method variable, and since all of these different instances, no matter which class we actually created an instance of, all of those instances would contain a process payment method, we can just call payment method dot process payment, and that's all we need to do. So let's give this a try now by creating a new instance of our checkout flow. We're just going to say let checkout flow equals new, and we'll create a new instance of our checkout flow class. And now if we call checkout flow.checkout with the string credit card, well, what that'll do is it'll create a new instance of our credit card payment method class and call the process payment on that. So if we compile this code now with TSC, and we'll run the corresponding JavaScript code by saying node strategy.ts. Oops, let me try that again. Node build/strategy.ts, of course. What we'll see is that it'll say collecting the user's credit card details. And likewise, if we try and pass a different argument here, such as PayPal, well, if we save that and recompile our code, oops, let me just try that again. We'll clear it out and we'll recompile. And then we'll run build/strategy.ts. Sure enough, we see that it says sending the user to PayPal for verification. And last but not least, if we pass Google Pay as the argument there and recompile it, if we run node build strategy.js again, we'll see that it says sending the user to Google to pay. Cool, so that's the strategy pattern. It's pretty straightforward, and it's really just a helpful way to implement multiple different ways of doing something in a reusable way, right? Because now if we wanted to add another way of collecting payment from a user, right? If we wanted to allow the user to call in and give their credit card details, then all we would need to do is just create another class called something like phone call method. And we would just make that implement the payment method, and all of the logic for that would go into the process payment method for this class. So it's a pretty simple way of just ensuring that your application remains extensible and you can continue to add different ways for your users to do things, different ways for your program to process different events, and so on. So anyway, hopefully this has been helpful for you.